As I said, today's topic will be clamper circuit. Before this, we have discussed clipper circuit, which is a circuit used to clip or cut or remove some portion of signal. We call it clipper circuit. We have discussed positive, negative clipper circuits using diode. So today we'll see another wave shaping circuit called clamper circuit. So what's a clamper circuit? It's a circuit to shift a DC level of a signal. What we call it a clamper circuit. We are not changing the shape of the signal, simply shift the signal, any signal. As you can see here, this sinusoidal signal is applied to a clamper circuit. So this input signal is shifted upward, as you can see here in the output. The whole signal, this AC signal, is shifted upward by some DC level here. Okay, so before we apply the signal to the clamper circuit, let's see this input signal. It's a sinusoidal signal with peak value of Vm, maximum voltage, on the negative minus Vm. So peak to peak will be okay. So here on the negative side minus Vm, right? So peak value Vm minus peak value minus Vm. So what will be the average value will be Vm maximum plus minus Vm divided by 2, right? So this is a maximum, this is a minimum. Average means we add the 2 divided by 2. So what will be the average? The average will be, because Vm and minus Vm is equal, so average will be 0 value. So this average value, as you can see, it is 0 here. The DC value of this signal, what you call it, the DC, the average value of this sinusoidal signal is 0. The average value of this input signal is 0. So what we need, why we need a clamper circuit? Clamper circuit, as you can see here, it changes what? It changes the DC level of the signal to any desired value. You can increase or decrease the DC value. But here, originally the DC value is 0, which is the average value of this sinusoidal signal is 0. Now when you apply this signal to a clamper circuit, this DC value or average value of the signal will be changed. So let's see this output signal here. After the signal passes through this clamper circuit, now what is the maximum value? Let's say again the input signal. Let's say maximum voltage 10 volt maximum. Okay, peak value. On the negative side, we have minus 10 volt. Right? So what will be, this is peak value, this is also peak value. What will be the peak to peak value? Peak to peak value of the input signal will be 20 volts, right? Peak to peak value will be 20 volts here. What is the average value or DC value on the input side? Is 0 volt on the input side. Still we are on the input side. Peak to peak 20 volt. DC value, the average is 0, because 10 plus minus 10 divided by 2 will be 0 average. Now we applied signal to a clamper circuit. The signal is shifted upward. Now this peak value, in this case, will be 20 volt. I will show you how it becomes 20 volt. And the minimum value becomes now 0 volt. Okay, so we are not changing the shape of the waveform. The waveform shape is the same. The only effect here is signal is shifted upward by some DC value. We are inserting or adding some DC value to the input signal. In this case, the DC value, the average value is 0. But in this case, the DC value will be this much, some amount of DC value. This is the average value. What will be the average value here? What is the maximum? This case will be 20. Minimum voltage 0 divided by 2, which will be 10. So here you see 10 volt DC. We get here 10 volt DC at this condition. Where this additional DC comes from the clamper circuit. I will explain you later how to construct a clamper circuit. But here I'm trying to define a clamper circuit. Clamper circuit is a circuit, wave shaping circuit, which is used to change DC level of a signal without changing the shape of the waveform. Okay. So what is a clamping circuit? As you can see here, a clamping circuit is used to shift a signal either upward or downward by adding or subtracting some DC signal. That's what we call it a clamper circuit. Clipper circuit, which is used to remove, cut some portion of a signal. But clamper is to shift your signal either upward or downward by some DC voltage. DC means here the average voltage. So when we say the clamper circuit, it does not change the waveform. Here you see the without changing the shape of the signal, simply change only the DC level, the average signal. In this case, the average will be at 0 level, but in this case, because the signal is shifted upward, as you can see here, the signal is shifted upward, so that average value now becomes 10 volt. From it increases from what? It increases from 0 shifted to 10 volt. Previously, the signal was like this, right? Signal was like this, so the average was 0. Now the whole signal is shifted upward by some amount of DC value, right? Shifted upwards. Now the average becomes 10. That's what a clamper circuit means. Okay, there are two types of actually 3 types of clampers, but for time being, let's discuss the 2 types. Clampers can be 2 types: positive clamper and negative clamper. So what's positive clamper means? So as you can see here, the circuit, we call it positive clamper when the signal is pushed our circuit will be positive clamper when it is pushed upward. As you can see here, it is called positive clamper when the signal moves upward. We include a positive DC, positive average. We add a positive DC component to the signal, the clamper circuit is called positive clamper circuit. So here you see a positive clamper circuit because this signal is shifted upward. Okay, as you can see here, it is shifted upward. We call it a positive clamper. Circuit is called negative clamper. Same signal. By the way, you can apply any type of signal. Same signal applied to this clamper circuit. Now the signal, instead of shifting up, it's shifted down. Right? So look, this type of clamper circuit is called negative clamper circuit. So we have two types of clamper. You can shift, move your signal upward by some positive DC, by adding some positive DC signal, or using negative clamper, you can shift or move your signal downward by subtracting some DC signal from our AC. So how we define negative clamper? A circuit will be called negative clamper when the signal is pushed downward. Okay, pushed to the negative side. We call it a negative clamper circuit. So to summarize, a clamper circuit adds positive or negative DC component to the input signal. Okay, it can be pushed either positive side or negative side, as is illustrated in this diagram. Okay, so the first one is positive clamper, second one is a negative clamper circuit. I will explain you later these two circuits, positive clamper circuit and negative clamper circuits. Before that, if you have any question, let's see. Any question?
No.
Any question, Jasmine?
معانا السؤال بدون جديد.
Muradin, any question? Either you can write your question on the chat, or you can ask me. Now you can ask me by audio. What's a clamper circuit mean? Any question? Is it clear?
Yes.
It's clear? Okay. So just to revise what we have discussed so far, we are discussing clamper circuit, another wave shaping circuit. We call it clamper circuit because we discussed so far. We discussed before clipper, which is used to cut or remove either it is negative or positive clipper. Here today we are seeing another wave shaping circuit called clamper circuit. It's not used to remove or cut part of a signal. A clamper is used to add or change the DC level of the signal. That's it. The AC signal, the waveform remains the same, no change. The only change is the average or the DC signal. So here, for example, this signal has a peak value of 10 volt, okay, and minus 10 volt. Okay. So what is the peak-to-peak voltage? Peak-to-peak voltage of this signal will be 10 minus 10. From here up to here, it will be 20 volt. Okay, 20 volt. After clamping, what will be the peak-to-peak voltage? This is now maximum becomes 20 volt because it is shifted by 10 volt DC upward. This 10 plus 10, it will be 20. Minus 10, if you shift it by 10 upward, it will reach the 0 value here. So minimum will be 0. So what will be the peak-to-peak voltage here? Peak-to-peak voltage of this AC. 20 minus 0. It is what? 20 volt. So you can see here, when you clamp a circuit, peak-to-peak voltage remains the same. Right? Peak-to-peak voltage remains the same. The waveform remains the same. We are not adding any energy here. Okay? Simply the average or the DC level. If you try to measure by a DC voltmeter, the DC voltmeter reads here how much? It reads 0. DC volt, not ACD. The DC voltmeter, if you bring a multimeter which measures DC voltage and try to measure here, your meter reads 0 because we are measuring DC. But here, your DC meter reads 10 volt. Okay? The DC value shifts from 0 to 10 by this clamper circuit. The DC, the AC voltage, the waveform, peak-to-peak voltage remains the same. Even the AC, if you read this by AC voltmeter, RMS value, which means square value, of this input and output signal remains the same. So the only effect from a clamper circuit is to shift only the DC level of the signal without changing the waveform and the peak-to-peak voltage. Is it clear?
Yes.
Okay, I have one question. I have one question here. What's difference between negative clamper and positive clamper? Okay, that's good question. So what's the difference between negative and positive clamper? So negative clamper, this is a positive clamper, as you can see. We'll come to that. I will show you later. This is a positive clamper circuit. Okay, this is a positive. We'll see that. And this is a negative clamper circuit. We'll discuss these circuits later. But now, what is the difference between positive and negative clamper? So positive clamper shifts the signal upward. The whole signal is shifted upward. You can do this at home by using your simulation software, TINA software. So as you can see here, construct simple circuit. One capacitor, one diode, and one resistor. This input signal, which is the blue one, the green one is the output signal. So what's the difference between these two? Only the signal is shifted upward. Okay, the waveform, peak-to-peak value, everything is the same. The signal is shifted by some constant DC voltage upward. That type of clamper is called